Here is a tutorial along with some coding excerpts from our class CS121. We're going to be working on the PowerPoint found on our website called Data Types and Expressions. So we're going to open that one up. It's going to look like this. So I'm going to do some live coding alongside with you along these slides to demonstrate the examples as we go through them. So here we go. The objectives for this particular lesson are that we need to be able to classify various types of data in a program, use data and variables and expressions, identify and resolve issues with integer division, and differentiate between objects and primitive data types. All right, we're going to go back and thinking again. Remember about strings and variables. Strings are objects, and an object is a complex data type that is composed of smaller pieces of data. And those smaller pieces of data are known as primitive types. So we have our string here. It is an object. We are holding the value CS121 in the variable course name. So that's how that would work. And string, being an object, is capitalized here. We're going to code that up real quick. So I need to get my Eclipse up and running. I'm going to pull this over here. And I'm going to begin. I'm going to have an organizational thing here. This is my data types and my expressions. I have already created the project. I'm going to now write, and again, creating that project, file, new, Java project. I created that. I named it week 2 data types and expressions. On that, I'm going to right click, and I'm going to create a new class. And I'm going to name that class data types and expressions. And I'm going to import the method, my main method, public static void main, right there. So now I have some way to do some coding. Okay, the beginning of that was dealing with some strings and it's an object. So we have a string object. We are going to call it course number, and we're going to assign a value to that. CS101, and we're going to put a parenthesis or semicolon at the end. Now, string being an object, we need to make sure this capitalized. As you see there, without that capitalization, we will have issues. So now that it has been resolved. Let's have a course name as well. And let's put that as Computer Science 1. And let's have a full course name. Oh. Course number plus. And we're going to put a semicolon in there. And then we want to see what we do with a printout. So system dot out dot print line, and in there I'm going to put the variable full course name, and I can then print that out, and we can see down here in the console what we have. Prints out CS101 semicolon computer science. I think that I want to have a colon here, not a semicolon. Change that, and it should look a little bit better. Now that's better. Okay, cool. So continuing along with our PowerPoint presentation, primitive data types. There are 8 primitive data types in Java. For numbers, we use the bit, short, int, long, float, and double. For characters, we use the char data type, and for Boolean values, we use Boolean. We'll get into greater detail as we go. Numbers, whole numbers. These are numbers that do not have a decimal point. We can use the values of a byte, a short, an int, and a long, depending upon how much information you want to store in there. A byte You can store from negative 128 to 127 different values. Short is approximately negative 32,000 to positive 32,000, and an int is negative 2 billion to 2 billion, and a long is negative 9 quintillion to positive 9 quintillion. Floating numbers, these have decimals in them, so they're not whole numbers or mixed, or maybe just partial numbers. You can use a float, and that would have 6 to 9 significant digits following the decimal point, whereas a double will have 15 to 17 significant digits. These are highlighted. The int and the double are highlighted because primarily we will use those two values. They hold enough data that we will not worry about. For the most part, they hold enough data and they don't take up too much space. So primarily we will be using ints and doubles. For instance, we have this scenario here, number of students. It is type integer, and we put a value of 10 in there. If we were to have a final value where something like seconds per minute, which does not change, we would capitalize that variable name and put the term final in there. For double, we could use, say for instance, tax. Maybe it's 6 cents to the dollar. We would want to put it's the data type double because it is going to have a floating point or a decimal. If it is something like pi, where that doesn't change, 3.14159, etc., again, capitalizing it and putting the bit final in there. Characters, we use char. So like int and string, we have char. And these will store a single symbol, like a letter, a number, an escape clause, or an X. Something like that, a variable, an X. So these can store any symbol from the Unicode set, character set, but typically speaking, we use more of the ASCII character set, which is a smaller subset of Unicode. If you want to print a special character, you'll use the escape sequence U followed by the code. So let's try that. So we have a char, and maybe I'm going to name it Smiley. And I'm going to put a value in there of a single quotation /U263A. And I'm going to run that and see what we get. Oh, sorry, I need to print that. I'm not asking it to do anything. So I'm going to do a shortcut here for my systemout.println. If I were to type in there SYSO control space, it should pick that up for me, and I don't have to type as much. And then inside that, I'm going to print out the variable Smiley. Now it has a question mark here because it's not understanding what this is. So we need to go in and change some configurations so that it picks up that we're doing a special character. So underneath run, we're going to go run configurations. And over here under common, we're going to go to change our encoding from other down to UTF-8. Apply that, run that, and now we have our smiley face in our console. Again, that's run configurations. Over here up to the common tab, under encoding, change it to other UTF-8. Okay. Alright, continuing along here. Booleans, they only hold two values, and they are reserved words, true and false. So they can represent two states. Maybe they can do an on and off state. They can do a true and a false. So things such as naming that Boolean is done false. So you could have a program that will keep running, and until that is changed, it will maybe run until is done equals true. We can also have things like too small, has fur, can talk. So let's code that out real quick. Just put a little bit of some Boolean values in there and maybe see how I can change that around a little bit. So I'm going to say that Boolean is done equals false. And I'm going to try to create a scenario where maybe I can get it to report out as true. So right now, if I did a system printout and I said I want to see what the value of is done reports out, I'm going to get this value down here, and it's going to say false, because currently Boolean is done is false. So I just wanted to check to see if that was working, and I'm going to report that out later. I'm going to put a little bit of a is done. This way I know what that is. Done equals. That way, when I run it, I have a little bit of a label there so I can see what I'm working with. So I'm going to create a scenario here to maybe change that. What if I had a value like, say, x equals 6? Okay, wait, it doesn't like this, that x is not. It says here that it needs to, well, I need to create a local variable. And so I'm going to say maybe I needed a type int. Okay, now it's been resolved. So now it knows that it's an integer. I'm going to say maybe if x is greater than 5, then is done equals true. So x is 6, x is actually greater than 5. So hopefully now we will change out is done should change to true when I run this. Okay, so we have changed that value for the Boolean value. We've toggled it between true to false. Okay. Let's fiddle around a little bit with this and have some fun. Practice is important. So what we want to do now is we want to declare a variable to represent the number of students in this class. What type will it be, and what name will you give it? Well, let's think. We need to initialize the variable to the number of students in the class right now. When I'm imagining that I would want that to be an integer, because if it's a number, I have two main choices, an int or a double. And I would assume that we don't have partial students, so it's going to be whole numbers. So I'm going to declare a variable and initialize it to the number of students in class. So let's say we have a value. So say, for instance, you do need to declare what type it is. So if I just were to make a variable, num students, and I said we had 12 students in class, it's not liking that because it doesn't know what type this num students is. So I'm going to say it's an int, it's an integer. Okay, that works. So now it's all right. Now suppose one new student enrolls in class. Write a statement that will assign a new number of students in this class to your variable. Okay, so we have one new student added. I could do just simple addition to that and then print that out, but I also could make it a little more universal. So maybe, for instance, it's at the beginning of the year and students come and go. So I might need to have more than just one time. I might say int new student, and it said 1. So then I'm going to want to print this out and to see. So if I were to print out, do a system printout. I did a system printout, and I were to say, let's add these together. We could say new num students plus new, not equals, plus new students. I would have a new, I would be able to print that out, and it should add those together. Let's see what happens. 13. So it took the value of num students, which was 12, and added that new student to that. Now, say for instance we had another student added real fast, I could just simply run that, and I have a new value of 14. And that would continue along as we did that. Let's see if there's anything else requested in this. Assign the new number of students. Write a statement that will assign the new number of students in this class to your variable. So I need to probably have a variable that is going to house total students. And at this time right now, I don't know that value. I just need to initialize it to something. And so what I could say is I could do total students is equal to num students plus new students. And I would not print this out. I would just simply have to print out total students. And I'm going to do a little bit of a label there. So now then it says total students in class is 14. Okay. It said maybe next it says declare and initialize a variable that will store the name of the new student. A new student. We're going to call that new student Bugs Bunny. Okay. So let's Bugs Bunny is going to be a string. And we're going to call that new student. And the value of that is Bugs Bunny. And I could print that out if I wanted to. We just do something like new student is the new student is Bugs Bunny. Finally, declare a variable to represent whether or not we're having fun in this class. So it is a either or, which would then be a Boolean. So we could do Boolean having fun is equal to true. Okay, so we would have something like that. And you could again go back and toggle along with that. Maybe we have a way to do a quick vote in class. We would say we might have two variables, int like is equal to a certain value. Let's just start it right now at 0. We don't know. And let's say int dislike, and again we're just going to give it an initialization of 0. And then I could say we could do a conditional statement. So that's if like is greater than dislike, then having fun equals true. Else, which would be here, having fun equals false. And then I'm going to print out my value for having fun. Print out having fun. I'll just print out. Okay. Now, right now, the values are at 0 and 0, so I could do like a hands up if you like the class, and maybe we have 5 people that like the class, and I could say hands up if you dislike the class, and they're like, this is really hard. I want to say like I don't really like it. So now then, at this time, we should see that there are more dislikes than likes. And let's see what happens here. Having fun is false. We're not having fun. But that is not the case, because there were lots of kids that didn't actually vote. And when I talked to them, they're like, oh, yeah, we were having a lot of fun. We were over there coding. We didn't get a chance to talk to you. So now then, I'm going to say, yes, we are. That needs to go down here, sorry. Now we're having fun. It's true. Okay. Cool. All right. Let's keep moving along here. Expressions. You should probably be familiar with most of these: addition, subtraction, multiplication, and division. And those are the symbols that we use. But we're going to add one more into the mix, which is called modulo, or remainder. It is not percentage. When you see this, it is referring to modulo, and that is just dealing with the remainder of a division problem. So let's look at how that works. We will get to that. But right now, let's just work on some mathematical expressions. To start, we're going to focus on integers, not anything floating. So we know that the volume of a rectangular prism is going to be length times width times height. So if we have some values for length, width, and height, we can also multiply those together to get a value for volume. So we're going to say length is 10, width is 5, and height is 15. And then we're going to try to code that out. That matches up with, make sure I get these correct. That matches up with that. That matches up with that. That matches up with this. Okay, so I need to stay with inside that bracket there. Now that bracket matches up here, so that's the end. So I need to stay inside this bracket here. So boom, boom, boom. So I can code inside here. Okay, so let's say we have the variable int width is equal to 5, int is going to be equal to 15, and int is equal to 10. And we need to have a value to store that in, so let's say we have int volume at this time. And we're going to start off with it being just a 0 because we have to have it start somewhere. So we're going to say volume is going to be equal to length times width times height. And that should hopefully come out when we print this out. Volume equals 750, and that is correct when you multiply those values together. Now, mathematical expressions here. To start, we're going to focus on integers again. We're still working with just integers, not floating points. So let's build a package of cookies among some friends. So the equation is going to be just basically number of cookies divided by n, which is number of friends. So let's have, for instance, we have our starting value of 12 cookies. We have 6 friends. So we need to divide those up together to find out cookies per friend. Let's code that out. So we have here int num cookies is equal to 12. Int num friends is equal to 6, and we're going to say int cookies per is going to be equal to num cookies divided by num friends, and let's print out let's see what we get here. So each friend gets 12 cookies. Okay, cool. Now, what if we had an odd number of friends? Like, say, for instance, we had 12 cookies, and we had 5 friends, and if we did that division, it would actually come up to, we have 2.4 cookies per friend. But we can't fit a decimal into an integer. So it's going to truncate them, means it's going to drop that decimal off. So let's try that. I'm going to change my value of friends to 5 instead of 6. So right now we have 2 right now. So right now I'm going to say we have 5, and we're going to run that again, and it still has 2. But there's a 0.4 cookie that's not being had, and I want my 0.4 of a cookie. And if you think in large term numbers, like banking and business, if you're not able to take those fractions and use them and you lose those fractions, even if it's close to a whole number, that's going to be tremendously impacting your bottom line. So we need to be able to hold those values. What we want to do is we want to change this around so that we can cast. This is what we call casting. If we want to keep the precision, we need to treat the integers as doubles and store the result in a double. So we have these two values. Number of cookies is 12, number of friends is 5. But we now need to say that it's going to be a double here, and we need to cast this side as a double as well so that it can hold that decimal place. And as a cookie lover, I get my 0.4. That's almost a half a cookie. I want that 0.4 of a cookie. So let's rework this here and cast it so that we can keep our cookies. Okay, so let's see. So I'm going to keep that down there a little bit later. But I'm going to now change this to a double instead of an integer, and I need to cast this side to a double as well. And I'm going to, now let's see if this is going to work. Cookies per friend. Let's see, I might have got this right. 2.4. Okay. So now then I get to keep that 0.4 of a cookie. That's almost half a cookie, and I want my half a cookie. Modulo. So this is it is an important concept to realize, and you can use it for a variety of things, and we will down the road. So modulo is the remainder of a division problem. It's determining how many things are left over. So for instance, like right here, if we said 139 mod 6 is equal to 1. So let's see how that works. We have 139 divided by 6. As you go down there and you do your division, you have 23 whole numbers and a remainder of 1. So modulo is just the remainder. So for instance, 7 divided by 2 is 3 with a remainder of 1. 7 mod 2 is just looking for that remainder. It's good for encryption, it's good for decryption, it's good for a variety of things. So we kind of want to practice that a little bit and see how that looks. So we've got some values here, and it gives us the reporting out. But I'm going to code these up for us so you can see how that looks out. So modulo. This is fun. All right, so let's do a 14 mod 3. And it's just going to print that out. So I'm going to do a little print line here so I know that I'm just looking at modulo. Anything after that modulo. So we're going to have 14 mod 3. Again, that is 14 divided by 3, and what we're looking for is the remainder of that problem. So that is 2. So if you can think about that, 14 divided by 3 is going to be 12 with a remainder of 14 divided by 3. Let's look at that on the calculator real quick. 14 divided by 3 is equal to 4. So we have 4, but the remainder after that 4 times 3 is 12. So there's 2 left over. So there's your modulo of 2. So again, it's the remainder that we're looking at. So let's do another one here. 8 mod 12. So 8 divided by 12, let's run that. We have a remainder of 8 because if you think about it, 8 cannot be divided by 12. So there you have what is left over there. So let's see if I can even look at that. 8 divided by 12 is going to be 0, but we have, if you did it in long division, you would have the remainder of 8. Here's another example, 10 mod 2. So 10 divided by 2 is 5, and there is no remainder of that problem. So we should see that 10 mod 2 is equal to 0, because there is no remainder. 7 mod 6. So let's see, 7 divided by 6. Well, 6 will go into 7 one time with a remainder of 1. The remainder of 1 there. This one is interesting. We got so 0 mod 6. So that's 0 divided by 6. What is that going to run us? 0. 0 divided by 6 is 0. So we have a remainder there. Now this one will crash. So we can't ever divide by 0. So 9 mod 0 is going to throw us an error, because that is a dividing by 0 you can't do. And it'll give you that code right there. It says you can't divide anything by 0. So that throws you out as an error. Okay, keep going through our PowerPoint. Order of operations. These are evaluated from left to right in order of precedence. And we have to think about what our precedence here. So this is the precedences. We start off with parentheses. So those are the first things evaluated. After that, we will deal with urinary minus and urinary plus. And those are like the values of, like, say, a negative. You have to, if it is a -1, like a negative 1, you will need to make sure that it's not a 1. It is actually that negative value there. So that is, if you can see here down here, this is like that urinary is the positive or negative value associated with your number. Then you have to go into multiplication, division, and modulus, again from left to right. And then after that's resolved, then you do addition and subtraction and string concatenation, again from left to right. And then finally, you will assign the value from right to left. So whatever's on the right side of the equation will be then evaluated and put into the left side. So here's the way that this example here is given to you, but simply we would start off addition and subtraction. Well, again, we start off with looking for parentheses. There's no parentheses. Urinary plus and minus has been established. These are all positive values. Then we're going to go into multiplication and division, and there's nothing there. So then we're going to go into addition and subtraction, and we're going to go from right to left. From left to right. So that would be the first thing evaluated, A plus B. Then we evaluate that whatever we have from that, A plus B, will then be added to C. And then whatever we have here will then be added to D. And then whatever we have here will be added to E. So it's important we know these order of operations, because if you don't follow them, you're going to get all kinds of different answers. So if we look in this particular one here, first we see there's no parentheses. Okay, so then next we're going to be looking at, well, we have the urinary plus and minus, and those are established already. This is a negative value there. That's a negative D, so that's there. So that we have to make sure that we represent that. And then we're going to go to addition, subtraction, no, it's the multiplication and division. So from left to right, this is our first evaluation. So first we take B times C. Then we take D divided by E. Then we have addition and subtraction. So we have A plus B, and then we have whatever we resolved as for this situation, B times C minus D times E, and that would be your fourth evaluation. So again, it's real important that we know how to do these order of operations. Otherwise, it will get you will get tremendously different answers. So let's do a little bit of some fun here. So let's say we have int math fun is equal to 8 divided by 2 times 2 plus 2. And then we're going to print out what is math, the value for math fun. Let's run that. Now I want to put a little bit of a print line here so we know that this is a new line. It's easier for me if I just do some math fun. So that way I can differentiate on my. So now I have 10. Okay, so we look here. First we do addition. First we're going to do multiplication. Well, we have parentheses. There's no parentheses. So then we're going to then evaluate. You're going to do plus and minus. And that's done. You can see the positive values here, and there are no negatives. And then we're going to do multiplication and division from left to right. So we take 8 divided by 2. So that's going to be 16 times 2 plus 2. All right, and then that we will then go back and reevaluate. Now 16 times 2 is going to be 32 plus 2. So that should be maybe 34 is what I'm hoping. Let's see if I did my math correctly. Oh, we got 10. So I'm messing up here a little bit. So let's see. Oh, 8. Oh, I didn't do that. 8 divided by 2. Sorry, that is not 8 divided by 2 is 4. So that threw everything off there. Now, so that is 4. I'm sorry. So 4 times 2 then becomes 8. 8 plus 2 becomes 10. So I just, simple mistake there. Sorry about that. So now we have that value as being 10. Now let's throw some things in here and mess around a little bit and see if we can change these by possibly doing some maybe parentheses. So let's put in here, maybe I put a parenthesis here and there. So that will now be evaluated before we do the multiplication and division. So now then it's 16. It was 10, now it's 16. Because now instead the problem will look more like this. We'll say 8 divided by 2 times 4. So that is now our new problem. So 8 divided by 2 is 4, and then multiplication of 4 times 4 is equal to 16. So that's how we get that here. So again, order of operations is very important because it does change the values that you get. Okay, here's an activity. I want you to pause the video so that you can do this on your own. I would like for you to try to figure this out. What you're going to be doing is you should have the knowledge to write a program that will use variables and expressions to solve a problem. I want you to write a program that converts the value of all the coins in a piggy bank to fractional dollars and cents. Well, think about data types you're going to use, think about the variables, and think about your algorithm. Okay, so we have in here, we're going to have, it looks like 4 quarters. Let's say 1, 2, 3, 4, 5, 6, 7, 8 nickels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dimes, and 2, 4, 6 pennies. Should maybe come up to 246 if I counted right. I think that's correct. So think about how you're going to do this. Pause the video and create a program. Create a class maybe called Piggy Bank, and I'll start that here in a second, but I would suggest, just highly suggest, that you pause the video and try to make this program on your own before watching the video's explanation of this problem. Okay, so we're going to make a new class here. I'm going to come down in here. We're working in this data types and expressions. I'm going to make a new class. And I'm going to call this class Piggy Bank. So I can fiddle around a little bit. And I'm going to put that main method in there. And I'm going to begin. So I have a new class here. And it's called Piggy Bank. So we're thinking about, we have 4 quarters, 8 nickels, 10 dimes, and 6 pennies. Those being whole numbers, I could use an integer to hold those values. And this is, again, there's various ways to solve these problems. Many algorithms will come to that solution. Here's just one. So we have 4 quarters, 8 nickels, 10 dimes, and then let's say I thought we said 6 pennies. Okay. So I have some values now for how many I have. But I want to be able to find a value for each of those. So a quarter is worth 25 cents, nickels worth 5 cents, dimes 10, and pennies are 1. So these are fractions of a whole. So you have a quarter being a value of 0.25. So I can't use an integer. I will have to use our double value. So, and these again are going to be probably final. So I could probably say final. Because the value of the quarter is not going to change. And I could say final. And I could say final. And final. Okay, that looks, oh, I didn't spell double right. Okay, and we will need to be able to store all of these into a variable that we will then print out the value of that variable, which houses all of those. So I need to be able to make a variable called Piggy Bank. That might be what I would use. And I'm going to say it starts off with 0 in there yet, and I haven't deposited anything. Now I'm going to have a pretty good idea that there will be fractional amounts in this, so I will need to make that Piggy Bank a double. So Piggy Bank is going to be equal to, and remember when we wanted to force certain operations, we use parentheses. So inside here I'm going to say number of quarters times quarter plus number of nickels times the value for nickel plus, again, just keep going along, number of dimes times dime plus number of pennies times the value of penny and let's see if we're going to print this out. And I'm going to say, put a little $sign there so we see how much it has in there. Plus, Piggy hopefully, if it runs correctly, we should see that we have $2.46. Just like we should see here, 246. Okay, so remembering, what are you storing? If they're whole numbers, we're going to use integers. If they're fractional numbers, you use doubles. The reason I said final is because these values here, quarter is always going to be worth 25 cents and etc. Now, if I were to change piggy bank and I said this is going to be an int, now it's going to have issues with all these because this quarter is a double and this is a double, so it's saying you can't do that. So it's going to have some big issues with that. And if I casted them to ints, we're going to have big issues here. Let's see if I can just cast all that to ints, because now we have done that casting. We are going to lose some values here. Just like we lost the value of our cookies, we lost some of that money there. So that's an important concept. So back at it, we should have now, we want to keep our change. It's important we keep our change. Okay, we have assignment operators. It is common for the right hand and the left hand of an operation to contain the same variable, and that happens. So we can use it as like a count is going to be equal to count minus 1. So then if we had a value of count saying, and again we evaluate according to order of operations. This is important. We need to do the right hand side first, then the left hand side. That's important to understand that. So we start with our right hand side. Say for instance count is 5. 5 minus 1 is 4, so a new value goes over here and makes that 4. When we do this, that assignment operator, we first start on the right hand side, we evaluate that, and then we assign the value to the left hand side. So there are some shortcuts to this as well. We can do some things, but let's first kind of code that out a little bit to see what that looks like and play around with it a little bit here. So I'm going to mess around with this is pigment. I'm going to go back to what I was working on here so that I can keep going on this line here. So say for instance we had a counter. So I said it had their count is equal to count minus 1. Now, we have a problem here because it's going to say here count. We don't know what it is. So we could say it's an object, but that's not going to work either. I'm going to say it's an int. And it says it hasn't been established yet. So it says the local variable may not have been initialized. So we don't know where count started. So in order for us to evaluate count minus 1, we need to know where count starts at. So what we could say is int count is equal to 5. Now, count is equal to count minus 1. That will work now. Now that we have a starting point, we can actually minus from that starting point. So we're okay here. So if we were to do a printout for we ran that, count down here is 4. Okay, so that's working. We can do it with multiplication. So maybe we say, but count anything times itself would not work. So I'm going to change this around real quick and say 2. So let's go back and reevaluate this 5 minus 2. Now we have count as 3. But let's say we're going to multiply that and change it to count times 2. We come down here and now it's 10. Okay, so that's working. We can do division. This isn't going to work very well because we're going to lose some values here as it's being it isn't 2 exactly because we lost our value there. If I were to say that count is 6, we wouldn't lose anything there because it's evenly divisible. We don't have that. We'd have to make that as a double in order not to lose our fractions. But we have ways to simplify this a little bit too. We have the plus equals minus equals, times equals, divided by equals, modulo equals. And basically it's shorthand for taking this and changing it from count is equal to count minus 1. You can just do count minus equals 1, and you're going to get the same thing. So let's go back to the way it was, where we had minus. So 6 minus 2, we run that, we get 4. Now let's try it. Count minus equals 2. And we run that. So I commented this out, so that no longer is going to run in our code. We should get the same value of 4 down here. Count minus equals. So that's shorthand to do that. So let's try maybe, remember we're going to multiply now. So count times 2. So that should be 12. Okay. Now count divided by 2 is going to be 3. So that's shorthand. So this here is shorthand for doing that there. We also have what's called an increment and decrement operators. These are the plus plus and minus minus. So these are the same effect as count is equal to count plus 1. So count plus plus is shorthand for count is equal to count plus 1. Count minus minus is the same as count is equal to count minus 1. So let's practice that a little bit. So I could say count is at 6, and I could go plus plus, and we're going to run and see what that is. So count is now at 7. So it just adds 1 to the value of count. And so we could do minus minus to see what that does. So that's going to be minus minus. So that's just decrementing. So we're going to go up and down by 1 value. So maybe that'd be fun for a program that keeps a score. Like every time you hit something, it goes up 1. Every time you miss something, it goes down 1. So that would maybe be a shorthand way of keeping track of some sort of a counter. Okay, so let's think about this here. We have number of students is 30. We're going to decrement by 1. We're going to add 3. Then we're going to multiply by 2. And then we're going to add 1. So that's kind of interesting. So, okay, let's see if we can do this. So we have 30 minus 1 is 29. Plus 3 is 32. Times 2 is 64. Plus 1 is going to be 65. So let's code that out to see if that is right. So int number of students is equal to 30. Now, it didn't, yeah, it starts with an integer. So now that we have a value, so let's say number students minus minus. And what we're going to do here, I want to do a print line that we follow along here as we do this. So I'm going to run this here. So right now we have done decrementing of 1. So we're at 29. So number of students plus equals 3. So 29, and we're going to add 3 to that. I made a mistake there, so our plus equals 3, I think. Wait. Plus equals, yeah, I keep on typing around. Plus equals, there we go. So we are at 29 plus 3 is now 32. And now we're going to take that value and we're going to multiply it by 2. Let's put an equal sign here. Run that. 64. Number of students plus plus. we run it, and we should have 65. Okay, so that's kind of how you use those shorthand operators. Okay, wrapping this up, we should know what our primitive data types are. We should know what an integer is, a floating point, character, Boolean expression, and modulo. That's a quick run through for your slide show, data types, and expressions. Thank you.